Hey, hi guys. So in this video, we are going to cover the bank transaction concurrency problem. Let's first go through the problem statement. So in this one, we are having multiple threads or multiple users who can access the bank account at the same point of time, be it the ATM user, be it the online banking. And these are the operations which you want to achieve, which is deposit, withdraw, get balance. When we say multiple threads here, you can say you have one bank account, some withdrawals are happening, some credits are happening. So in that way, requirements are like basically we need to make sure that we are creating a system which are thread safe, no race conditions during the concurrent transactions, and balance never reaches a negative. Basically, we are not allowing any user to debit more money than what they have in their account, and making sure all the transactions are deadlock free. I mean, so that is what we are looking to achieve in this problem. The basic solution to kind of have in this one is just creating a simple class. If you see here, so we have created a simple bank account class where we are having the deposit, withdrawal, and some other function which all are all are synchronous. So what do we mean by synchronous here is if any one if any one particular thread is using any one of the function of this object, then this object will be locked for any other threads to be used. They cannot kind of use any of the functions until unless the thread one which is using this object releases this. Let's go through the simple test cases. For example, let's say when you say account.deposit, it kind of locks this entire object and it adds the 100 to the final balance, which is this one. The case 2 is when we are having concurrent deposit. Basically, concurrent deposit would mean that when you are getting the multiple credit transactions, like someone is sending you 100, someone is sending you 50, in that case also this will work fine. In terms of overdraft prevention, what if you are trying to withdraw more than what you have? Even in the concurrent situation, this will still work fine, because whenever you are doing any operation, you are locking the entire object. But there is a case where this may not work out. What if you have two objects? Okay, let's use this code. Okay, now let's say we have two objects. So one is the bank account B1 and other one is B2. Both of these are the instance of the bank account or the class. So let's say this. Yeah, done. Okay, the next one again would be this one. So these two are different bank account. They are not same. Okay. Now B1 is transferring some value to B2. Okay. Now B2 needs to send some value to B1. Will this transactions work or not? So let's see how this will work. And these are happening concurrently. Okay. So B1 we want to send B1 money from B1 to B2. That means we will be calling B1 dot withdraw. Okay. We will be calling B1 dot withdraw and B2 dot deposit. The above transaction will only work if you are having the lock to both of the objects. Okay. Now let's come to the next transaction, which is will be B2 dot withdraw and B1 dot deposit. Now, do you see that? Is there any way this can lead to the deadlock situation? What if I say that B1 has called the B1 dot withdraw at the same point of time and B2 dot withdraw at same point of time? That means now B1 and B2 objects are locked. just because of withdraw, just because of the withdraw operation, just because of withdraw operation, withdraw. Okay, now when they will try to do this b2 dot deposit, that also requires the synchronization. That means you need to have the lock on the b2, but hey, b2 is already locked. Similarly goes for the this transaction also. Now what will happen, we will enter into the deadlock because the first transactions needs the lock on the b2, the second transactions needs the lock on the b1, and they both are already locked. So if we go with this solution, then we are definitely going into the problem of the deadlock situation. Basically here, if you see, we are trying to transfer the money from one account to another account. Okay, so here you can see we have two threads, T1 and T2. T1 locks A but wait for B, and T2 have already locked B, and it is waiting for the A. So we have entered into the deadlock situation in this case. Another problem with this solution is we are synchronizing everything. Even the get balances are getting synchronized. So just the read, we will be having a performance issue during the object which we are using. If you want to check the balance, it kind of blocks the entire object. If you want to withdraw the money, it blocks the entire object. If you want to deposit the money, it blocks the entire object. So definitely it have a performance issue it will have a performance issue in the production. Now there may be another problem which is related to the compound action. So if you guys are not clear, so compound actions are those which are composed of the multiple action. For example, when you are trying to increment, when you say I plus plus, it is not just a one operation, it's a multiple operation. First you get the value of I and then you add the one to it. So here also we may face the same issue basically. What if this you got this one, okay, let's take this one, this is interesting one again, copy it. Now let's go here. Now how this is bad, okay, let's see. So you let's say it's b1 dot get balance and b2 dot withdraw. Now what will happen, let's say you call this dot get balance, okay, it will lock the entire object, so you will get the accurate balance at that point of time. But in between this, see, when you reach this line number 19, now the thread is released because the get balance work is done. In between this, what if balance get updated by another thread? If this happens, that will be a very bad situation. We will be in a bad situation in that way. Okay, although we have a check here where we are checking whether before withdrawing, just check the balance, but still we may be doing multiple processing here inside this one. So when you are checking this one and when you are withdrawing this one, it may not be the correct to even call the withdraw, because in between 18 to 20 the balance have got updated. Maybe they have already withdrawn the money, maybe something bad has happened, whatever. So this is what the issue we have with this compound operation. Okay, we have more problems with this solution which we are covering in our course, and the approaches also, like this problem can be solved in a much better other ways if we want to kind of reach the scalable solution.